Okay, so 1.2, day 2. So continued. We need to get some vocabulary in. We need to know what standard position is for an angle. Okay, so standard position for an angle is, let me... give you a coordinate plane. The initial ray lies on the positive x-axis, and the vertex is at the origin. And it can rise and fall from there. It doesn't matter. Okay, but standard position is initial ray along the positive x-axis, and the vertex is at 0, 0. When we do our problems or work on things, we will want things in, we'll want to draw angles in standard position. It makes it easier to work with. So an example, we need to, says draw a 45-degree angle in standard position and find points on the terminal side. Okay, so 45-degree angle in standard position. So you make your X and Y axis. How are we going to know where 45 degrees is?
It looks like it.
Well, how would you describe 45 degrees?
Acute, half of 90.
Half of 90, it's acute. So I need to cut the first quadrant in half. So we draw an arrow up showing as a positive, and we write 45 degrees. So what would happen if I continued this? What line is this? What y equals mx plus b line is that? What's the y-intercept of this line?
0.
0, right? And what's the slope? What do you think?
X.
X is up 1 over 1, yeah? So this equation is y equals x if that was a line, right? So give me a point on that line. On this angle, on this ray, give me some points. You just told me the equation was y equals x.
2,
2,
2.
2? Kyan, give me one.
3,
3,
3.
3? Oh, you guys are going. Sam, give me one.
7, 7.
7, 7? Could I have square root of 2, square root of 2?
No.
Where does square root of 2, square root of 2 come from?
30, 60, 90. 45, 45, 90.
45, 45, because 2 have to be the same.
Mm.
So if I took and made an imaginary right triangle here, square root of 2, square root of 2, and then 2. You got a triangle. Okay, so do you see how when we know a point on an angle, can we make a right triangle? Can we then solve it with Pythagorean theorem?
Yeah.
Yes. Okay. The next thing we need to talk about is if an angle is in standard position and the terminal side is in quadrant 1. Okay. So an angle that is in standard position, right here, we did this, right? Here was our angle, 45 degrees. It's in standard position. We would say theta lies in Q1. This right here That word you say when you see it is lies in. So theta lies in Q1. So if you had to describe this angle right here, theta lies where? Q3. So what is that? It's just a C. It's like an E. Some places, what? Isn't there a... I don't know. There's a school that uses an E like that. Make sense? Lots of vocabulary in these first sections. Okay, the next thing we have to go over is coterminal angles. Okay, so coterminal angles share terminal rays. And I will usually say sides, but it is a ray. So if you remember where the initial ray is here, terminal ray is where it stops. Terminal ray is what makes the angle, right? So co means share, correct? So they share terminal sides. So if I were to draw an angle here, and I told you this angle was 65 degrees. Okay? It's probably not quite 65 degrees. I don't know. And I wanted to share this terminal side. Well, that means I'd have to move what? All the way around to get back up there, wouldn't I?
Yeah.
Okay. So what is like here? Sorry. I'd have to go past it and then go all the way around to hit it again. What angle would that be? If the first one's 65, what would the blue one be? How far did I have to move? 360 degrees. So the first one was 65 and I had to go 360 degrees more.
It's still 65.
Well, it's not still 65 because an angle degree shows movement, but it would be 65 plus 360. So 5, 2, 4, 25. Could I do it again? Yes. What happens if I go not positive direction, but what if I went a negative direction? So I started at the positive x-axis and I went around and stopped here. Would I still be sharing a terminal side?
Yeah.
Yeah. But how would I find that angle? I wouldn't add 360, I would subtract. So I'd have 65 minus 360. So 5, 15, 9, negative 295. Could I subtract 360 again? Go negative another rotation. So I'd have 5, 5, 6, negative 665 or 655. Is anything going to stop me from continuing to go a positive 360 or negative 360 to find coterminal angles? No. There is an infinite amount of coterminal angles. What is my magic number to find them? What have I been adding and subtracting? 360.
Why'd you subtract 360 from 295?
Because I said, let's find another one. So if I was here, and then I said, like, I want another one, wouldn't I have to go another 360 degrees negative?
Yeah.
So I can keep going as much as I want. So 65, 425, negative 295, and negative 655 are all coterminal angles to each other. There is no limit to the amount of coterminal angles there are. None. Okay, so it says find one positive and one negative coterminal angle to negative 47 degrees. Then find all of the coterminal angles to negative 47 degrees. So if I said 360 was my magic number, correct? Okay, could I use 720? What's the connection between 360 and 720?
Just twice.
It's just twice. Okay, could I use 1080?
Yeah.
Because that's just 3 times. So any multiple of 360 I can use, yes? When you look at your answers in the back of the book, they will do they will add 360 and then subtract 360. But could you do it more? Yes. Okay. So I have negative 47 degrees. I usually add first, then subtract, but it's up to you. So plus 360 degrees. So what do I get there? 315? 313, not 15. I wrote 13. Okay. Then I subtract 360. So, negative 407. Make sense? Now, I haven't showed you all, have I? Because you can't, can you write all of them? No, because there's infinite number. So all, we put negative 47 degrees, excuse me. The book only puts plus. I put plus and minus, and I'll explain to you why. 360 n degrees. What does that n do for me? How's that give me all of them?
You can, pick how many you wanna do.
Right, you can pick. So when I want all of them, I'm going to have an equation, right? Because I can't possibly write them all. So positive, negative, and all. Make sense? Coterminal angles are important because as we move further along, we will know the sine, cosine, and tangent for 45 degrees. So that means any 45-degree angle, that is any angle that is coterminal to 45 degrees, we will also know. So it takes an infinite number of answers down to one. So they do have a place. They are important. They make things easier to work with. One more example I want to do with those is what happens if I want a positive and a negative coterminal angle to 536 degrees. Okay, so how do you want to do that? I need one positive, one negative coterminal angle to 536 degrees.
The positive, you just do it once, but the negative, you
Do what? What do you want to do?
plus 360.
Okay, so if you do 536 plus 360, you get 6, 9, 8. Okay, so I'm going to put stars next to my angles that are coterminal. Does that sound good? Okay. Then what were you saying, Alex?
But to get to negative, you have to do the 360 minus 360, but you have to do it twice.
Okay, so he's saying you have to do 536 minus 360, and I get 6, 13 would be 7, right? And 4 would be 1. Guys, isn't this also a coterminal angle?
Yeah.
And isn't it positive? Yeah. So could I just subtract twice and get both of them? Yep. And then minus 360 again,
Why are we doing it twice?
because I need one positive and one negative, and 176 isn't a negative number yet, is it?
Oh, okay.
Oh, I hate subtracting backwards. Anybody else? 4, 5, 8, 2, 1. Did you guys get negative 184?
Yeah, because you did.
Okay. So what I was trying to say is I don't always have to add to get my positive coterminal angle, do I? I could have subtracted once and still had a positive angle, and then just subtracted again and gotten to my negative. So when you do these on a test, I'm not going to, I will test whatever you give me and see if it works. Now, again, if I wanted all of them, it'd be 5, all of them. It would be 536 plus and minus what?
N.
Not n. You put something before the n.
360.
360 n. And then your degrees. Now, the reason why I put plus and minus shows direction, correct? So if you don't acknowledge that direction, I don't know how you get all of them. I don't. Now, they are saying n can be negative, and that's why they do it. They say, well, your n can be negative. Well, n is the number of times you do something, yes?
Mm-hmm.
Can you do something a negative number of times? No. So that, to me, that does not make sense when textbooks do that, because you can't do something negative number of times. Okay. I think that's it for today. It's just coterminal angles. What do you guys go through? 53 through 81 on? They'll throw in some distance and things. Yep, that's it. So today is coterminal angles. So do you think it's important?
What page is it?
It is page 25, 53 through 81 on. And when it says, like, one of them says, actually, let me give you one thing, because it's going to say figure 22 on page, like, use figure 22, so you have to go back. So let me give you that figure. Let's draw it, so then you guys have it.
2.1.
Good catch.
Okay, so this way you don't have to go back in your book. Okay, so we have a circle. We have 0, 0. Yes? So if I draw this angle, what angle is this? I just drew. What do you think it is?
What?
30.
45.
45. Why 45?
Split it.
Ow.
Split it in half. Okay, you need to come back and be quiet and listen. Okay, I'm going to give you guys these real quick because I think it's going to make it easier to draw this. Can I keep these? They're mine.
I do
Straight
what I
edge?
want, Miss Minnie.
Okay,
There's some-
so if I do through the first quadrant, can I continue this through the third quadrant? Can I do that? Okay. And then find where it would be in the next, in 2 and, it's hard.
2 and 4.
Yep, 2 and 4,
So another 45 each.
basically. Okay, so this right here, and we're going to draw them, we're going to put the numbers on the outside. So this is 45 degrees. This would be 0 degrees, yes? What would this one up here be?
90.
90. What would this one be?
135.
But, well, this one would be 135, yes, but that's
What'd
what,
you- what'd you
that,
say?
this one.
Oh, my
180. I was going to go back to that one. And then straight down would be
bad. 270.
270. Okay, so all of these are 45, right? So this next one between 180 and 270 would be 180 plus 45, which would be 225. And then I'm going to subtract. When I go around, this is also 360, yes? Well, 360 minus 45 would be 315. If you notice, everything I do will be to the x-axis. And I don't know why I made that so long. Okay, everything is going to be from the x-axis up and down. I'm not going to talk about the y-axis much. Okay? So now, I'm looking here, and I want about a 30-degree angle. And these are rough drawings. We will have better ones later on. So this is 30 degrees here. And then you want to come and from the x-axis, kind of eyeball another 30 degrees. And draw through. We're going to label those. So if this is 30, so 180 minus 30 is what? 150. So the one in the second quadrant is 150. It's what you call a 30. It's what you call a 30-degree angle in the second quadrant because it's 30 degrees away from 180. Okay? So when I go to the third quadrant, I'm going to add 30 to 180 and get 180 plus 30 is 210. So 210 degrees is the 30-degree angle in the third quadrant. So in the last quadrant, I'm going to subtract from what number? 360. So 360 minus 30 would be 330. Okay? Guys, where am I getting 30, 45 from? Where are those coming from? What triangles?
Right.
The special right triangles, right? Because we got the 90, don't we?
Mm-hmm.
And we got the 30 and the 45. What are we missing? What?
60.
The 60. So the 60 is going to be like right up in here, yep.
Job at circle.
Yeah, I did draw this.
Well, like I said, we'll draw a better one. This is just for today. Because it says use figure 22 and it's hard the way your book is. So we're making you a figure 22. So 60 degrees in the first quadrant. So 180 minus 60 is 120. So 120 is the 60-degree angle in the second quadrant. And then 180 plus 60. 240. So 240 is a 60-degree angle in the third quadrant because it is 60 degrees away from the what? X-axis. Okay? So 360 minus 60. So 300 is the 60-degree angle in the fourth quadrant because it is how far away from the x-axis? 60.
Oh, that's what I meant.
Yeah. So this is figure 22. Let me see what. You'll need it on like 61, 63. 53, 55, 55 through 63 odd, it says use figure 22 to complete the following. Okay? So, these, remember I told you you're going to have a big old chart on your final? It's actually 75 points on your final. You've worked on it since day one of Trig. So by the time you get to your final, it should be 175 free points on your final, correct? And these are your angles. These are all the angles that are on there. Now we'll do these in radians and degrees, and we'll do them sine, cosine, and tangent of them, but these are the angles. The sooner you know that 45, 135, 225, and 315, excuse me, and I forgot my degree, are all 45-degree angles, then you know the sine, the cosine, and the tangent for all of them. Okay? As sooner you know that 60, 120, 240 and 300 are all 60 degree, you know those. Okay? So, today I'm going to say use this so you can find the connection between these angles, but after that I'm going to say work at it. Don't go look at the picture because you have to know them. And if you know them, it will make this class easier, it will make calculus easier. I've seen kids in calculus not know their sines, their cosines, and tangents of these angles and struggle because they can do the calculus, but they can't finish the problem without looking it up. And it takes them twice as long to do. Okay? So that's your figure 22. We will have a nice one that I give you a printed circle and we will put all this lovely information on. Okay? But this right now is your figure 22. I think mine turned out pretty good. Did yours turn out that good? No.
Mine looks like a mess.
Okay, it is on page, would you like to know what page it is on so you can go back and look if you need to?
Yeah.
It is on page 22. Figure 22 on page 22. At the bottom. Well, I mean, once you know what it looks like, you could see it. So this assignment should not take you long.